Hi everyone, my name's Sophia. I'm part of the marketing team here at Curiosity. Today I'm joined with Toby and Huw Price, and we're basically doing a webinar on before you migrate, what nobody tells you about the data. So just a bit of housekeeping to start off with. So we got a chat function on the side, so you can either chat with us individually with the private chat message, or feel free to use a public one as well, and you can ask any generalized questions through that way. We also have an interactions feature too, which there'll be some polls going out throughout the webinar, so make sure to keep an eye on those ones to interact. A bit about each of them. So Huw Price here is our co-founder and chairman of Curiosity, known as a serial test data inventor, worked with the world's largest organizations to transform their test data management. With Toby, he's one of our solution engineer. He's a test data expert with over a decade of experience, helping some of the world's largest enterprises solve complex data challenges.
Okay. Hello. Hey, Toby. How you doing?
I'm doing good here. I'm excited to be here. Yeah, data migrations is something I've dealt with for even before I was with Curiosity. So yeah, it's going to be good to chat about it.
Yeah. I mean, in my several companies, we did actually have a company called Move to Open. I think we moved about between 6 or 7 mainframe customers off the mainframe. So we saw it all in those spaces. Okay, so let's get into it. There's a lot to cover today. Hopefully we can squeeze it into an hour. There will be some small demos, but nothing too dramatic. Sophia, if you have any problems with audio or anything, just call me on WhatsApp or something like that. That's a problem. Because sometimes I have been talking to the void in the past. So it's going to be a little bit chatty in terms of how this goes. It's mostly me presenting the slides with Toby adding a bit of color. So we're going to kind of talk about, to start with, just a rough agenda, common issues with migrations, and we between us, I think we've seen an awful lot of problems. So we'll kind of dive into that. Toby's going to talk a little bit about the kind of concept of a minimum viable product, which he's done a fair bit of work with in his previous lifetime. So then we're going to get into kind of understanding your data, and really AI is good in this space. Using AI for short burst, measurable, helpful stuff is a really good way of saving an awful lot of time. And I guess the main premise of this is do a lot more work on your data before you even begin the migration. A lot of people just kind of pile in from all different angles. And actually, if you use AI, cleverly and use some of the tools that AI has, you can actually shortcut a lot of the work you're going to have to do with the data. Now, obviously, we're going to talk about some deep scanning. We're going to talk about quality and a kind of a methodology of understanding and how you map the old world to the new. Then we're going to kind of get into the data migration strategies, integration points, whether you work parallel, what's observability? How do you know that something has been migrated correctly? Then handling private data and how you actually go about sort of dealing with outsourcing parts of the migration, and then the kind of testing strategies to go along with that. And then basically the kind of general migration strategies that you need to think about. This is actually probably a webinar on its own, but we'll just kind of touch on some of the core features that tend to go wrong with migration strategies. Okay, all right, Toby. So just to kind of, this is kind of pretty much, I think, the only advert for us, which is we've got a product which is called Enterprise Test Data. It is very modular, and we kind of bring this up at the beginning of most of our webinars. And the types of components that we would sort of be doing here is a lot about scanning, PII, deep scanning PI, building up a dictionary, data governance, because obviously you need to know what data you're masking, all that kind of stuff. A bit of synthetic data and a bit of data designing to test your migrations. So that's that. So let's just talk about the types of migration projects that kind of go at, the typical groups migration projects. Now, there's a pure platform migration, and I've been involved with probably maybe 12 or 13 of those. And that's really where you're kind of lifting and shifting from one platform to another. It's not so common nowadays, unless you're probably maybe moving off my mainframes, and there's still a bit of that stuff going around at the moment. The rule of thumb with that is do not change any functionality as part of the migration. The number of times people say, oh, this gives us a chance to do this, and let's make that change at the same time. I would strongly recommend for you not to do that. It just causes, you need to be able to test apples with apples, and if you start, throwing in oranges, it all goes a bit pear-shaped, to keep on the fruit analogy there. Change of architecture, 2 to 3 tier, that's pretty common. You're sort of switching into a more kind of API driven structure. The thing about that is you can actually make a lot of changes to your database prior to the migration to support the new architecture. So I'm sort of a big fan of actually doing prep work in the source system before you even begin the migration. Merging multiple systems into one. An example of this is you have multiple payment platforms, and you say, great, we're going to have a single payment platform. And I've been involved with several of these. Do deep analysis of the data from all systems, create a master payment object definition, map every single old to new, including uplifting missing data, because obviously you're going to have a Venn diagram where you've got more information in toto from all of the sum of the payment systems, and you need to uplift the missing bits. Completely new platform, homegrown to ERP. That's pretty common. Deep data mapping and data quality audit first. Decide on full or partial migrations, which we'll get into. Changing some middleware. Replace or add on functionality. For example, you've got a new pricing module to replace the old one. Now, the thing about that, fine, you're going to map all the data items from the old to the new, but the original system also now has extra information that needs to be trapped in your original system. For example, you're using an API now to do your pricing calculations. You're passing all the information into it. So why don't you just store the request and responses in your original source system, or maybe convert them into little mini tables as well? There's different things you can do when you're actually getting into the different types of migration projects. I'm going to talk a little bit about hopping strategies. So there's one which is you've got sort of 3 major components of your applications, 3 different databases, all homegrown. You've got products, customers, and order management system, and you're going to move it over to a brand new system, and they've got different functionality, ERP, whatever it is, product, customer, orders, and bingo, you just move the lot over. Everyone's happy. It all happens on over the weekend. Everyone comes in and starts carrying on. Everything's great. Sounds optimistic, doesn't it? Now, the other probably more common, especially with kind of large migrations, is to actually start picking off different modules. So you're going to basically the product part of the new RP is a pretty established, very straightforward component where you're just going to manage all the products over in the original system. But of course, you've now got a problem. You move that over, and all of your customer and orders need to make references to the products. So you've got to start thinking about, well, previously they were pointing at the product database, and now we're looking at a target database, which is elsewhere. So you've got to think about the middleware that you're dealing with to actually get that to work. Now, that could be simply changing SQL to go through to that. It could be that you've completely re-architected that in terms of you're using kind of a message middleware, something like a Kafka or something like that. And what you'll end up with in the middleware is some kind of transformations, usually both ways. So, one table might have merged into 2 or 3, or objects or API objects, and the reverse, a product back in the original system was actually split into all sorts of different things, and you've got to kind of think about how do we split that back up in the middleware. So that's we've done that in the past. That's actually reasonably strong, being able to do that. You've obviously got to understand everything as you do it. Then the other one is really this synchronization, where you basically just you're living with both worlds. You're putting all of your updates and everything within your product system, and it's literally just synchronizing back to the original system. And there's lots of different ways to do that, message logging, database logging, et cetera, et cetera. The thing with that is it has to be so robust, because what you don't want is suddenly messages sort of sitting on queues, not making it over, and you're running your end of day and the products are not there and all sorts of things like that. So that can be, synchronization is a world in itself. You've got to be very careful about it. The number of migration that's failed entirely, are late to deliver, or get partially finished is crazy high. I mean, you know, the number of, I think one of the best ones was an enormous bank, which they hired, I don't know how many thousands of people to move to an ERP, and you know, a new CIO came in and just cancelled a lot. So guess what? They ended up with both systems. So they ended up paying for the ERP and maintaining the old system, because it was just causing an absolute fortune. And now they're completely stuck with a completely messed up hybrid system. So what's the common issue with migrations? A lot of upper management has bought into the hype. You know, they've been taken, you know, to Napa Valley. They've been told the wonderments of the particular ERP that they're going to do. It's going to solve world peace, etc. And the problem with that is there's a devil in the detail that they really need to understand before they buy into the hype. Toby, any thoughts on that one?
Yeah, it's people get. This reminds me a lot of the SAP migrations I've been part of, where everyone gets very excited by SAP S/4HANA, etc., and then they get really bogged down into a lot of. You start getting really bogged down into the details, and everything just gets so slow and so slow. And I'll be coming on to minimum viable products later.
Mm-hmm.
It also reminds me when we were talking to our friend at the tax office, where he was talking about a migration where they had to reset every year because the tax rules kept changing, and they were trying to migrate everything over, and they never got they took them like 7 years to do the actual migration because they kept having to start from the beginning again.
Yeah, that sounds about right. Anyway, so let's keep cracking on. The understanding of these systems is quite poor. You know, I was sitting in a room with, I think, like 10, more than that, about 15 VPs, me and a guy, Paul Blundell, and we could not get them to agree amongst themselves what a share trade was. And they all had been working for their bank for probably about 15 years, and it was hilarious watching them trying to work out what a share trade was. So Paul and I went away and we ran a whole bunch of queries, and we came back a week later and told them what a share trade was, because they didn't know. The understanding of a new system is obviously not available. You know, you need to skill up on that, and that is obviously difficult to do when you're actually trying to maintain the old system as well. The other thing, which is the problem, is that data has changed over time. You know, which is you've brought on different systems, you've already done migrations, you've you know, I think we did some work with Nationwide, who are very good, by the way, and they had obviously merged in several other building societies under them, but the data was brought in, and they made the decision to actually not upgrade the data to be sort of nationwide compatible, which was fine, because they knew they ring fenced it. They knew that it didn't carry all the same information. But of course, if they then try and migrate that system, they've got this kind of historical data which doesn't conform to the current schemas and metadata. The other thing is bad data will exist, and the projects actually become an enormous data cleaning exercise before you actually start. So you've really got to go down into the weeds and kind of have a look at the data itself to see how strong it is, what kind of data, or every single assumption has to be verified. Keeping going. Migrating systems is complicated given the number of integration points, and especially nowadays where you've just got, I mean, talking to an ex-colleague at Morgan Stanley, you could have 800 systems lurking around, just moving transactions from one side to another and back again. So if you're starting to migrate, one smack in the middle of that, you might have 40 to 50 integration points to worry about. Now, this is one of my hobby horses. The complexity of pretty much everything in IT is not the numbers of lines of code. It's how hard is it to test. So for you to actually test that the the migration is working correctly before and afterwards. It's how much testing do you have to do, and that's really a good rule of thumb in terms of how difficult this migration is going to be, and how hard it is to test. Now, the other issue, of course, is that teams are much more fragmented nowadays, and it's difficult to get clear cooperations and lines of sight across application functionality. First of all, we're not in the rooms anymore. We can't just do what we can't get together and have a whiteboarding session. You've got DBAs in one place, you've got security people in another, you've got environment people in another, you've got the middleware team in another, you've got you've got the business analysts, you've got the lines of business. So actually trying to get everyone together to get a clear cooperation is pretty tricky. And the other thing is
if I could just jump in on that, like I think migrations, I think out of all the projects I've been on, that is the most difficult thing, because you have so many different key stakeholders, and if somebody's not being given their primary job to be the migration, they don't want to touch it because it's really hard. So they'll keep they'll keep denying your meetings, etc. See, the amount of times I've had to use my escalation points for migration projects is just, for me, is much higher than any other project I've ever been on.
Mm-hmm. Yeah, sounds about right. And the other one, and the reason for that actually, is that everyone's busy. They got people saying, "Now we need this new feature. We got the competition is doing something. We need to have dynamic pricing, whatever it is." And meanwhile, there's people saying, "Oh no, we're going to be moving to whatever the flavor of the month ERP is." So let's keep going. I've mentioned this before. The temptation to add in new functionality to the migration, almost always a bad idea. Now, the exception for that is, as I hinted at before, is to add in new data to support the migration. So we'll get into that in a little bit more detail. So adding in extra fields, everything is the concept of being observable. Did you get the right answer for the right reason? And the only real way to do that is to put in kind of observable points. So as you're migrating, you say, this made it to this point, it's this type of transaction for these reasons, and then when you pick it up for the next part of the migration, you kind of know where it's come from and why. Phase migration of components is tricky. Where is the central point of truth, which comes into the minimum viable product? I'll leave that to Toby to pick up. Phase migrations, you need to feed forward and feed backward, then hop from one migration point to another. Again, that's probably more to do with minimum viable product. And the other thing is that every single thing you need to do needs to be tested thoroughly. So if you are going to hop from one place to another and move over parts of the system, you've got to basically test every single piece of that migration. Now, the other one, which is absolutely monster, is if your migration fails, you need to have a complete rollback strategy, which you have tested. The example is 8 payment systems, which were being merged into one, turned it on in the morning. By 9 o'clock, 96% of the payments had gone into manual validation. I can talk about that why later. So they had to back the whole thing out and replay all of the payments through the original 8 systems. So had they tested that? Actually not. So it was kind of by luck that they managed to actually get the payments paid. So it needs to be designed and tested. So those are the kind of things you need to worry about when you're actually building any of these strategies. Have you got a fallback position? So moving along, over to you, young Toby.
Yep. So when I've been working with data migrations, the thing that has really been hammered into me is making sure you've got a minimal viable product. Now, what do I mean by that? I mean, what is it? What is the minimum amount of data you need to be able to get your day job done on day one? Now, from what I found, now the 80-20 rule is an economics term, but it is actually being able to use in multiple facets of life. And I actually think it works very well with data migrations. And what I mean by that is 80% of your features or your outcomes, that what you need, is probably actually going to be done by 20% of the data. Now, that's incredibly beneficial if we think about all of our data mapping tables, and especially as how business rules and databases start to change over time. That means you can actually narrow down your scope of the data mapping you need to do, and actually how much of the data migration you need to test. Because if you've got less data, you'll be fine. Big bang rewrites, personally, I've never been involved with one, because I think by the time that I started working on them, most of the time they're not seemed as viable. Vast majority of the time, we're now on to phase approaches, because it just means that you can you can start doing everything in small little bites. The minimum viable product is really used for that. If you migrate some bad data into your systems, as Huw was kind of saying, you can break the whole thing. So actually, it's much better to keep that bad data in a archive system somewhere where you can retrieve it with your previous system. Don't migrate it over. Don't scupper the whole migration. We were talking about management buying into the hype. They'll be asking you why isn't the migration delivered when you're still trying to figure out some payments from 10 years ago. And I think something which is very important is your data minimum viable product is going to be very different to your feature minimum viable product. You'll probably only need about 20% of your data. I've had maybe like 5% of the data actually done to actually achieve the vast majority of the features you need for day one. Keep them as separate different work streams. Have somebody map out what your features you need for day one, and then have somebody map out what data they think you need for those features. And then, so this is one of my favorite stories is actually when you've got two very secure systems, people often forget about the actual migration and transferring the data. So I was doing some assurance for one data migration for the government for some of their weapon systems. And there was some data which it was from a on-premises to the cloud. And we were doing some assurance, everything was looking really good. And they were asking me, why is it so slow? Turned out they had one laptop that was able to connect between the two different systems. So they were trying to, I kid you not, so they were trying to migrate petabytes of information through one poor consultant's laptop. And then they were kind of going to like, well, why is this so slow? And so at that point, it was really, really important to try and minimize the volume of that data to be as small as possible to get over, because otherwise it was going to take a very, very long time to actually migrate the data through this poor person's laptop. So yeah, I think, yeah. And then often people are they know about the features of their tool. They actually have a very good understanding of what their tool's able to do. You ask them about the data underpinning that. It's one of the age-old phrases like, do you understand your data? Most people don't. And that follows on to the data migration as well, is that people don't understand the data behind it, and therefore they underestimate how much time it's going to take compared to the features.
Okay, cool. So let's crack on. So I'm just going to drift slightly into this idea of kind of breaking things into the components. Now, there's tons of really good tools out there which can actually analyze code, especially if you've got your own code, whether it's COBOL or C# or Java or whatever. And actually what you're looking for is this clustering of code, because what you'll find within those clusters of code, you'll actually can be able to map them into the data back to the data itself. You can look at the SQL, you can look at the SQL that these particular clusters of code are actually managing. And that then is this, but what we're trying to do is to build this idea of the data mapping into business functionality, which Toby was just kind of alluding to there. And you can actually get some, especially with AI nowadays, and there's actually some really good companies that we've worked with in the past that just are brilliant at being able to chop this code up and give you some really nice breakdowns in terms of how the functionality. You've got the application, you've got the code itself, and then that can map down to the data, which is quite useful. I'm not going to, that's a whole webinar just on that. So what do we do? And now we do this anyway, because we're doing a lot of work with test data or AI or building machine learning to test premises, etc., that you're interested in. So what we would do already is we are scanning everything, anything data that you have within the organization. We would be scanning it. We're looking at all the data itself. We're looking for the structures of the data. We're looking for data growth as it moves forward. We're looking for potential relationships within the data to try and understand how all the data is related at the kind of almost the bitty byte level. The foreign keys are fine, but mostly it's the other. I mean, you'll be lucky to get 10% of your foreign keys in a schema. There's probably another 90% you can actually just reverse engineer directly out of the data. The other one is documentation. I mean, it's almost unheard of to see a fully documented schema, or even JSON structures. It's pretty rare you find a Swagger spec. You just find some JSON structures. So first of all, you need to just do some basic scanning. AI is really helpful with this. You know, the auto updating of documentation pointed at your Confluence pages, and bingo, you've auto updated it, and suddenly you've got an actual something which is really a robust understanding of the data that you've got. Ideally, if you've got an ERP, you should already have this. Otherwise, we could just do the same and scan the ERP and build out the kind of source and target mapping. The other one there is the categorization for PII, which is understanding what data within that is actually problematic, which I'll get into a little bit later. And also, the other one there is data validation. Once you've started to understand that, you can run scans to see, well, how much bad data do I have in there? So if we're going to migrate this data, you've really got to understand which bit of the data that you're dragging over. And if you've got broken links, you're going to end up with kind of orphan data or data that's just kind of left hanging because there's no way to get to it. And that's going up and down. So for this, AI can be a massive accelerator. We use it all the time to help us build the understanding. We just kind of built it into our framework to just go and scan as much as possible and build this and put it into this central dictionary. So now, just to quickly kind of talk you through the methodology, we scan the basic structures. I think most people kind of understand that. That's the tables and JSON structures. Then you start getting into the univariate analysis of, you know, mins, maximums, all this kind of stuff. You know, basically any sort of lists of things. You can then actually start looking to see what relationships you've got between things, because you can recognize from the characteristics of columns that they look very similar. Therefore, there's probably some kind of relationship within them, and that could be across multiple databases. Again, we're looking for personal data, across technology relationships. Ignore these two over here.
If I could just jump in, that cross
Yeah.
list relationship finder is possibly what the favorite thing that we have in our tool, because I cannot tell you the amount of meetings that I've had to do where you are dragging one SME from one tool, one SME from another, and then trying to get them to agree on the relationships can be so painful. And if you're doing a migration across multiple systems, that is one of like the biggest pain points from my personal experience.
Yep, sounds about right. Again, document orchestration, and then the latest one we're working with machine learning, which is actually really useful. And we'll talk about how you test systems as well. And machine learning can be quite useful for generating high volumes of data, so you can test the migration before you actually do the migration. So what you end up with is a centralized data catalog. That's very useful for AI, by the way, because you have a deeper understanding of the data. So if you've got prompts, they really do need to, it's no point throwing a prompt at data you don't understand, but I would say it is almost identical in terms of its usefulness for migration. So now, the other thing that we do is this kind of trying to do suggested relationships. We triage the relationships. You know, this is what we think the relationships are. And again, this can be cross technologies. And out of that, we would then go off and actually do validation. Now, validation usually throws out bad data. Now, there's a few things going on here whenever you validate and you end up with something that this data doesn't fit, it doesn't match. First thing is you've got the rule wrong. Great, no problem. You just remove the rule. Bingo, you fix that problem. The next one is rule context. So you may well have, if the order type is, so if the order type is group, then it's not actually linked into a customer at all. So all of the customer, you might have a parent ID, which doesn't match with some of the customers. And the reason is that that order is a group order. And that means that it actually doesn't have any parents associated with it. It has a master order number. So what you need to do is understand the rule context at the very kind of low level. So the rule is valid in terms of moving the data over. So if you're pulling data from customers and you get a link back to the orders, that's fine. But you do need to understand those rule contexts. So there's quite a lot to it. That again, that applies to AI. And the other one is bad data. So the question then is, what do you do with the bad data? Do you just leave it? Do you try and repair it? And this is when you start coming back to your CIO who's been to the Napa Valley and say, right, for us to clean up this data, there's pros and cons. Are we just going to carry it over? Are we going to allow the bad data to live in the system, but we're going to mark it as bad and we deal with it there? You know, you have to be absolutely honest about the amount of work that bad data is going to cause you when you actually get to the migration itself, and you absolutely need to kind of have it in a bucket as bad data. And what are you going to do with it? Okay, and there's a couple of ways you can deal with that, which we'll talk about later. So now let's just look at understanding your tables. Now, a lot of this stuff you can kind of infer by some of the scanning that we did before. Reference tables, most people can probably go through there. So say if we say an average database has got about 1,200 tables in it. You look at them, most people can probably pick out the reference tables, and you might probably spend a little bit of time looking at some of the tables. A lot of the tables will be called ACE underscore FS underscore ref, things like that. You know, so they're not the most they're not the most obvious names for you to understand. It's a reference table. Then there are transactional tables. Now, transactional tables tend to be a lot, you know, there's a lot of data in transactional tables. A lot of the business logic can sit inside metadata rules, but you absolutely need to know that the metadata rules are linked with, you know, why did that order get processed in this way? Because we've set up a whole bunch of metadata rules which are processing it. Flex tables. So, you know, Oracle has loads of flex tables, flex columns, where you basically call column F01. Oh, that is the customer drop-off location, you know. Now, when you come to masking, you need to understand that. There's obviously parent entities and child entities. Sometimes you'll say, well, when we look at the relationships, there are only parents. Now, that's pretty good clue that it's a reference table. And then you start getting into kind of what we call business core objects. You've got to start now doing this mapping from the raw up into the business objects. Child entities, business attributes, joining and linking tables. You've got lots of tables which just join stuff together. You know, they've got very little data in there apart from, say, we've got a many-to-many relationship between things. And then there's aggregate and audit tables. Some of those are just, you know, made life easier because you can do your end of day balances and they're just kind of aggregated data that's pulled up, and you can rerun it and rebuild those tables. So you don't particularly need to migrate those, for example. The audit tables, those are just sitting there as audit tables. But then once you've kind of gone through this obvious stuff, you then get into this absolute ton of temporary tables that just kind of are there to support the building of the aggregate. But they look like real data. So what do you do with it? Archive data. People have just chucked some data over to the side because it was bad and we're just going to leave it there and eventually someone will get to it, but they don't. Bad data, repair it or ignore it. And then the other stuff is just lots of tables you've got absolutely no idea what it is. So, you've got to be kind of honest about, does anyone know what this table's for? Now you can do things, a lot of things you can do is actually is do some snapshotting of data and then see if the data is changing over time. And if no one is doing any changes to it, you can say, well, actually, we could probably lose that, or we can archive it and forget about it. The other one is one to think about is how are keys created. There are many methods of actually creating keys. Now that sort of becomes a problem later on when you're trying to migrate data in terms of how data is kind of added together. Are you using sequences, etc.? Are we going to migrate the sequence numbers over? Do we have an API call to create the new customer ID, which is based on location? So there's lots of different things you need to worry about. Now, as Toby mentioned, mapping. So I'll just talk about some of the things here and maybe you can pick up one or two, Toby. So obviously source matches to target. New target has mandatory data. So what are you going to do with it? You've got to add in specific data because there's not null columns in there. Or you found a whole bunch of source data which doesn't go anywhere. There's literally, we're just going to throw this data away. What are you going to do with it? You've got all this lovely juicy data, but the new system doesn't have anywhere to go with it. So do we have to go into the target system and add in a whole set of new kind of custom tables to support what we've got? All of these are the kind of horrible problems you're going to have to deal with. Business entity fully maps, great. Business entity has missing attributes. You've got a business entity, which is an order. Some of it is implied and some of it is aggregated. So that's aggregated up into that business entity, or it's kind of implied. Do you know where that aggregation comes from? There's the other one, which is quite a few of the migrations I've been involved with. What they've decided to do is to leave data behind, but it needs to be searchable. So there was various tools around, lots of kind of documentum type tools, where you would extract the data and put it into a forever store and put some basic search capability on top of that, which is fine. But the trouble is, it needs to be maintained, and someone's got to pay for it every year, and it's got to make sure it works. Now, the other problem there is you've got this GDPR stuff about someone calls up and says, "I'd like to be removed from your system," and obviously you've got a 7-year retention system, so you actually do need to understand that data, even though you've left it behind. If you need to remove it legally, you need to remove it. So you've got a problem there. How do you know that customer ID, which is not the customer ID that's in your new system, matches? So there's all of these kind of devil in the detail things that you need to worry about. Do you want to talk about mapping, Toby?
Yeah, so I've spent typically when I've been involved in data migrations, it's the mapping which I've been heavily involved in. And so sometimes when you do migrations, like 95% of the columns is like, oh yeah, same. And then you get to something quite difficult. One of the most difficult ones I've ever done was with some data mapping tables from ECC to S4HANA. And it was, you have two tables in ECC called LFA1 and KNA1, which is like for your vendors and customers. And when you migrate over to SAP S4HANA, they get amalgamated into one. You can only have one business entity. And it's really bloody difficult. It really, really does get very, very difficult with getting into a lot of the weeds. So yeah, and everyone just thinks, oh, it's going to be really simple, but you spend a lot of time, and then testing it can be really, really difficult. Most places you'll just have to do it from a logic perspective, and then you kind of cross your fingers and hope it works, or you might get a small subset of data. If you've got a way of creating data to put that through testing.
Yeah, you're jumping into my stuff now, Toby.
Sorry.
Hold your horses here, mate. Yeah. Okay.
Yeah.
Anyway, let's crack on. We've got a lot to cover. Sorry, we are going quite quickly, but we will be sending out a video, obviously, of this, and the slides. So don't panic if we've gone a bit too quick for you. Now, this is this kind of idea of rolling up column objects into business objects. You've got a payment, which is a transfer. Then you've got a concept called batch payments, and then you've got transfers, which are groups of batch payments, and you've got balances, which are derived from the original currency reserves, the currency exchange, and the institutions into the batch payments. Now, all of those map up into kind of column objects. You've got a payment at the bottom here, which is reference, institution IDs, etc. So in effect, the idea is kind of, it's some of the AI terminology is kind of moving around at the moment. So it's in effect a conceptual model. This is an AI jargon word, which is great. So much stuff they could churn out in AI. It's amazing. The knowledge plane mapping to the data plane. There you go. And basically, it's a bit like what I was talking about before. About you've got different customers, different types of customers, which would then have different kind of mappings from business logic to the data itself. So it's about understanding and modeling the business itself rather than a set of technical objects. So just moving on slightly. Okay. Now let's just think about the business objects themselves. Okay. Now this is where it's kind of what we ended up doing when I talked about the share trades. So we have within our tool a thing called a subsetting tool, which I'll just hop over. Hopefully all these things are still there. And basically what we do is we've kind of created a subset, and we're interested in purchase orders, and we've kind of gone off and shunted away and looked around and say, well, what are purchase orders linked to? We've gone off and built in a whole bunch of relationships. So I'm going to look at one purchase order, and we just looked at this purchase order, and you say, well, okay, fine. Okay, it's got a bunch of different suppliers associated with different purchase orders, etc. Then you get into the lines, that's looking fine. And then you come in here and you say, whoa, what's this? Last edited by number 6. What's that? So do we track that information over in the new system? You think, all right, well, there's an audit system, so they have users. So have we got a mapping for this? And what do we do about, people who've left? Do we have to go in and put them into the new system, because otherwise we're going to lose the audit about who actually did this. So even by just being able to run this subset for a specific purchase order, you're actually sort of starting to drive down into the nitty-gritty weeds. This stuff looks fine, and you're like, well, ooh, package types, ooh, right, right. So unit price, have we got that? So it's actually looking at the raw data itself is a really sort of good way of being able to say, did we map this? Supplier ID, that's fine, everything looks cool, and you can chuck this into AI and say, right, what am I missing here? But it's kind of a good way to be able to actually pull that data out using this kind of subsetting concept and just kind of expanding it. Now, if you guys, I'm a big fan of Neo4j, and actually what you can also do is just spend some time. It genuinely doesn't take very long. We've got some utilities to help if you need them, and basically you just start somewhere and just say, right, pull me out 5% of my orders and chuck them into Neo4j. And then Neo4j is really good at finding clusters of information, and you can actually just cast some very straightforward queries to see how your data is kind of tied together. And you can also say which data is not tied together, which is coming back to this bad data concept as well. So this idea of network database is actually a pretty good way to do that exploration with your data as well. Now, the other thing to think about here is that obviously we've been talking a lot about databases, but actually lots of data now is sitting in kind of relatively unstructured, obviously documents, but messages, API payloads, JSON payloads, flat files, etc. All of those things need to be analyzed as well, because they are our data. Now, some of it might be in flight, but some of it is used and ingested within the system as you're moving through integrations, etc. So the way that we do that is that we shred and parse the data itself. So we would take your 20,000 payment JSON structures and turn them into a database. Once you've got them in the database, you can do all of the stuff that we talked about before, all of the analysis to see, well, why does it match? Where does, as Toby mentioned, this ability to understand the relationships between, all of these different components. Where does that map? That purchase order seems to be appearing all over here as well. So when we migrate, we need to think about these structures, and we need to migrate these structures into the equivalent structures in the new target system as well. Out of that, you also get your trends, your coverage, your machine learning analysis, because then you can actually use something like machine learning to create a trained model and actually generate a lot more messages, which is then very useful for testing your migration. AI can be quite useful in this space as well. So I'm now going to jump into problems with migration strategies, and that's private data. There's the typical things you need to worry about. Dates. You'd think dates would be fairly standard by now, but absolutely not. You will have so many dates in there which are, 01 space 04 space 09. Brilliant. And the next one is 23 12 23. So, you're actually cleaning up dates you can spend weeks cleaning up dates, and you've got to make, again, compromises.
Huw, if I could just jump into that. I think one of the hardest data challenges I've ever had is when you get a system where you don't know where the date format's in, and all the dates are 0101 2022, 0101 2026. You're like, okay, yeah, I think this is UK. And then suddenly you work out it's American because it's gone 1225, etc. And I think
you'll find both. Yeah, you'll find both in there.
You'll find both. You do find both in the same data set, and then you don't know what to do.
Exactly. So then you've got to make some calls. Mainframe stuff. There's quite a lot of mainframe migrations going on. Probably got their EBCDIC values, binary values, all that kind of stuff. Again, you've just got to scan for them and make a decision. And generally, the very first, whenever you do a mainframe migration, you dump the first, your VSAM file, you bring it down, and the first 700 rows of VSAM data contain binary low values in EBCDIC, and you're like, oh, our migration doesn't work because you can't get the first 700 values in. So that's the type of thing you need to worry about with those. Bad data, as talked about, fully documented. There's pros and cons to decide on what you need to do about them. And like I said, sometimes a migration project turns actually into a data scrubbing, data cleaning exercise. And again, that's going to cost you money, and you need to get that costed, and you need to get that done before you even think about moving off the platform as well. Now, when it comes to scrubbing, you need to add in extra columns to explain what you have cleaned and why, because the problem is, this is my sort of premise, that basically you should start thinking about putting extra data in your source system. The reason we cleaned this up was because this, and the old value was this, because that then gives you some, when you do the migration, you've got some way of being able to track back in terms of where that data come from. You know, you've cleaned it up and you've made the assumption this is an American date. You actually put that in, that's the reason that we cleaned it when you do the scrubbing. So that's the kind of thing that makes life so much easier. Otherwise, you're just like, I had no idea. Suddenly the date fails. You're like, well, what happened? At least you've got something within the source data to give you a clue. Observable, did the migrated data get migrated for the right reason? I'll talk about parallelism later, and that's probably a better place to talk about this. Integration points, will the new system support all your integrations? Again, this is this idea of, you know, the bank where you're moving one system, you've got 30 integrations. Will the new system support? Does it contain all of the mappings to all of those API endpoints or flat files that you're either ingesting or creating? Do they actually map? Can you map all of those? So the mapping exercise is not just about A to B, it's about A to B, C, D, E, F, G, A, all the way up to DA, because there's 30 integration points. Now, parallel development of my data migration. Now, when we did mainframe migrations, we did a lot of them. We would have typically about 8 hops to get the data from one system into another. And, you know, for that, data generation is much more effective than live data for testing, and I'll talk about that in a second. The other one is extensive negative data testing. One of the biggest problems you have with migrations is it just lets through data which has no business being in the target system, which means you might have migrated the data and then suddenly, like 4 days later, the whole system starts to actually collapse because you've managed to let bad data into the system, which the new system does not have a clue what to do with, and you've got getting weird results, and then everyone's in a massive panic. Testing strategies, exact and fuzzy comparisons. You know, there are differences between system, and a fuzzy comparison means this is close enough. And again, AI is quite good for that, or you can just build your own fuzzy comparisons. Let's talk about data security, privacy. So the problem you've got, and this is absolutely massive, because generally you'll have a consultancy firm come in and say, yeah, we're going to migrate you. We're going to come to a fixed price. And then they say, yeah, give us your data. And they go, we can't give you your data because it's got all of this PI data in it. You say, well, how are we going to do the migration? Well, that's your problem. You have to scrub the data, and you just end up with people realizing they're going to have to spend $200,000 or $300,000 dollars or euros or pounds to actually scrub the data before they can be sent out. And when I say scrub, I mean really scrub, because you do not want to be sending your data offshore, or you have to bring people onshore into the business inside the firewalls, which is much more expensive. So the idea of first of all, you need to know what the PI data is, which comes part of our scanning, which is fine, but then you've got to be completely, that has to be absolutely costed into the how much you can start migrating your development systems, which in theory are masked, but generally aren't. But you've really got to cost it out in terms of how much that's going to cost. Practicalities, masking turns into a data quality project. The masking they cannot let data pass through that could potentially contain sensitive data, and you can't outsource your migrations, as I've said. And we're talking to a company in Boston, and no one's willing to pay for the masking. So guess what? They ain't moving. So that's kind of some of the things you really need to worry about. Let's talk about parallel. As I said, data migrations are broken down into multiple stages. These stages are preparing, matching, morphing, validating, unloading, loading, and transforming, roughly. And having teams waiting for upstream data is a waste of time and can make migrations run well. I mean, we did, I think, a Dutch bank, 2 Dutch banks. One Dutch bank was going to be taken over by another Dutch bank. The government said this whole project needs to be done within 6 months. And as soon as they started the migration, it was going to take at least 9 months for them to migrate the data, just to migrate data over. So they've got the data reformatting and validating, just to dates, all that kind of stuff. Then they've got to do the matching and enhancement, where you're going to have different codes, any other uplifting of data that needs to go ahead, and then you've got to get into your standard ERP data load, and you've got to have feedback loops where mismatched and bad data is feeding back, so you can adjust the rules and fully rejected data. So you're going to build this platform. Sounds great, no problem. Better way to do it, massively speeds up data, forces teams to communicate, as initially they have no data, forces team to build much more robust and data rejection processes. So you start with your data reformatting and validation. Meanwhile, your matching and enhancement team can start working, because you're synthetically creating the data that they are actually pushing into their transformation that they're building, and the same with the standard ERP loads. Now, what you'll find is most people, it would probably about 80% they'll get right in terms of what they think the data is going to come through. So this is, again, we do a lot of work with test data teams. The test data teams actually become the corporate repository of what the truth is. So when they'll say, well, create me some synthetic data, and they'll already have been talking to the data reformatting and validation team and say, well, actually, this isn't what the data looks like. The data looks like this. So having these in parallel, and again, for the Dutch bank, it was a mixture of one SI and the internal team. We managed to get the migration down to 3 months. Okay, and that was because we synthetically generated 7 of these stages to actually load the data in. We bolted it all together, and as we bolted each bit together, there were some few issues we had to deal with, but at least we were well ahead of the game. 3 to 4 times faster. The communication between the teams is utterly essential. So let's just talk about different approaches to actually how you actually test data. Now, mask data we talked about, which is basically you've gone to the trouble of masking the data and you're pushing that through. That's fine, but actually model data is by far a much better being able to do that, because you can create lots of negative data. And modeled, if you've seen some of our other videos, we spend a lot of time modeling lots of variations of data. Now, the example that we were using was coming back to the 8 payment systems that were going to be pushed together, and what had happened is they'd taken like a 2-month slice of data, which was millions and millions of rows, okay, and they were using that to test the migration. Now, the problem they have there is that it wasn't across accounting boundaries. Now, the trouble is, as soon as they did the migration for live, they then suddenly had a whole bunch of data which was across some accounting boundaries, which had a lot of data they'd never seen before, because it was reconciliations going backwards and forwards. So that's why the migration failed, is because they didn't have a really good spread of data. So we ended up generating actually tens of thousands of rows of data, but it was much more representative of all of the data that was coming in. Now, having 10,000 rows of data is a lot better than having 2 million, because every time they ran a test, it ran for like 5 hours, whereas with 10,000 rows, they could do much more nimble testing as well. So synthetic and model data is, I would say, almost essential for major migrations to be able to kind of keep the speed up and keep the quality up. Did the migration work? I'm going to quickly go past this, but basically what you're trying to do is you're creating almost a digital twin in terms of what your expected results should be. So you've got your source, the data's moving through the new system, it's coming out with some results. You're pushing the same data through your new system, and you're actually then for each of the different types. I mean, you can do it for one transaction, fine. But the trouble is, if you do the same test on another transaction, it's probably the same type of transaction. So what you need to think about is to modeling the variations of them, and either use it to pull out the different types of transactions that are going to be, that exist in the old system, and then you're going to compare them as you run them through the new system to make sure that the new system is processing, that you've got the same rules in there, that you've got the same calculations in there. And then you get this kind of like for like close enough, or transform comparison. So that's when you're saying we can't really compare the purchase order amount because they have a different accrual system. So we actually have to use a different method of saying this has worked as well. So there is kind of that type of thing you need to think about when you get into migrations. Okay, sorry, just before I get into the kind of summaries, any more to add here, Toby? Because we're sort of coming close to the end.
I just think on testing migrations of work that can be very difficult, and I think you're just about to your first bullet point. Yeah, migration data first. Like first you do migration, then you do all your data first, then you do all your reconciliations, etc. And that can take quite a long time if you don't have the right architecture set up to
Yeah.
get it sorted.
Yeah, so parallel, not sequential migration of data and objects, extensive and high testing of each migration. That's utterly, if you want this migration to work, because at some stage or other, you're all going to be sitting in a room and saying, right, let's go, let's start the migration. We're going to close the other system down and we're going to start the new system. You need to have tested it significantly, really, really well to make sure this migration, you might have had some trial runs already and all that kind of stuff, but absolutely, but not a full volume one. That's the problem. Usually the full volume where it all goes a bit peak tong. Aggregated up values into business objects, source target, that's basically this idea of trying to create actual business objects that make sense to the business. This is everything associated with an accrual. And we understand it from the source side of things, and we understand it from the target side of things. Once you start getting that understanding across, then the mapping becomes a lot easier. Carry references into the new system and backwards. So the references are the old purchase order number was this. So the new system, you've got flex fields, add in extra objects. This was, Nationwide took over Redwood Building Society. We've got the Redwood Building Society account number. Let's carry it forward. Who cares? Let's just move it into the system. If you're doing hops, then you can put once you move the data into the new system, you can backfill that into the orders of the original system, as a new field. It doesn't hurt. It's just data space is not the problem now. It's about the understanding and speed. Change the source system to support the migration before you begin. Spend a lot of time kind of cleaning up any issues, bad data, references, functionality that is kind of missing that you're going to need to be able to support the migration. So try and do some changes to your source system to make the migration easier. Break it into hops, as Toby's talking about, because it's just too much to bite off. Synchronized to support phase migration, robust and well. If you are using synchronization, you absolutely need to make sure it works and it's robust and well tested, because otherwise you end up with this problem of data not synchronizing in time, and then you got all sorts of issues and everyone's panicking. Build a migration failure plan and test it. So if the migration fails, what's the rollback position? Totally essential. It's not just because you've still got orders coming in. They're all stacking up in a queue somewhere. So if the migration is going to take 12 hours and at the 11th hour you've then got to go back and you've got to roll the whole thing back, which might take another 11 hours, and you've got 22 hours of orders to process. So there's all of this type of things you need to worry about. Building automated tests for the target system. Actually, this is a really good point. One of the partners we were working with this, we actually spent a fair amount of time with them building automated tests for the new system. So we actually put their automated testing was in place, even though they weren't using it in the target system. So when we migrated the data and started using the system, the automated tests were already there. Now that was quite useful because ongoing, they had a whole set of automation done for the target system, which was, so sorted the data out, got all the automation running on the target system, and they used that as part of the migration, and they also used it ongoing as well. So, moving things around, don't think of things in straight lines, think of things in maybe do this first, do that first, do this, all of that type of concept I think is something that's really kind of important in terms of how these things proceed. Summary. Do all the data mapping, cleaning, documenting before writing a single line of transform code, make any changes to the source system, model testability at phase the migration, look at non-migrated data, searchable data stores for historical backup, you may well, we talked about that, you might want to put them into some kind of document store, but you need to think, well, how are we going to maintain that? Who's going to pay for it? And does it get forgotten? And before you start anything, work out how much the migration is going to cost. Okay, just how much is it going to cost for the data before we even start doing the migration? Okay, and that's when you get into creating minimum viable product mapping. What's the benefit of actually doing this migration, etc. Map the application, the data hop synchronization, migrate, test the data migration correctly, change the middleware if you need to, and I think that's it. And we've actually hit that in an hour, Toby, which is amazing, even though it was probably at the speed of light. And apologies if we rammed too much in, but it is pretty much a massive subject here. Sophia, do we have any questions?
We do have one actually. It is, do you have like any examples of good and bad migration?
There was the bad one. There's many. I think it's crazy, like 56% of migrations fail. So there's a lot of examples of that. One was just where they had a code migration engine which they hadn't tested. So we were trying to provision the data in for the new code, and the code just hadn't actually, the migration engine just hadn't been tested, and that was just, it was mad, because they'd sort of started up the whole project with assuming that this was going to work, and what we ended up was testing that, which meant that in the end it just was not going onto stable ground. So that was pretty tragic. The good ones are a team that's quite, I think, who was I doing one with? Yeah, absolutely. The one we did with Disney, actually, that was because we were involved with the building of the new system. I think we were working with Accenture with this one, actually. They had, so we already had we built a brand new system from scratch. So we had complete understanding of all of the data across every facet of the business, from business intelligence to defining a hotel. Now, at the same time, we had the migration team who were moving all of the various different systems in. But because we had such a strong understanding of the target system, it was pretty straightforward to go to each of the source systems and to go do this mapping. And we literally uplifted, went through, we pulled out chunks of data, and because the target system was so well understood and the source system, we could just kind of slowly uncover it. We then kind of built a migration strategy, and that sort of started about halfway through finishing the build of the new system. I mean, some of the data we were kind of moving in as we were going along because they needed hotels, for example. But of course, the definition of a hotel changed probably 40 times during the actual migration. During the build of the new system. So we didn't really start it until we were about 30, into iteration 30 of actually pulling the data out of their old hotel management system. But something like that. So I might be making some of it. It was a long time ago I did this. So, but that was a really well put together, well thought out, and kind of sensibly done kind of approach in terms of how that project went. Toby, any good ones?
So I think my favorite one actually was a TDM migration we did, where we're working with a bank in Latin America, and we had about 1.5 months to get the Curiosity system up and running. But we absolutely nailed the MVP. So we only migrated about maybe 10% of the actual functionality there for day one, and that was like 90% of what they needed. And then we were able to add in bits and bobs afterwards. But yeah, that was a great migration. I really enjoyed that. I think the worst one, I don't know if it's the same one that you were talking about, but again, there was a code conversion from COBOL to Java. Migration
Yeah, that's the one.
engine.
That's
Yeah.
that's the one I was talking about. Yeah, and that was pretty bad. Yeah.
That was my least favorite, because again, I remember the guy was having to jump into a meeting, who had sold this tool. It wasn't working. Then he'd be pulled on to another migration project, which was also running and had the same problem. So he could never solve any of the issues, and it was just massive failure.
Anyway, onwards. Okay, so if any of you are in Oslo a couple of weeks' time, come and say hello, where I'm talking about this. And Sophia, any wrap-ups?
Yeah, I was just gonna say I popped a poll in the chat if you guys would like to book a meeting individually with Huw or Toby or one of our other team members, and they can answer any more individualized questions for you and your company.
Cool. Sorry it was so rushed. If you look at the recording, hopefully you'll get the points, and we'll send over the slides to you so you can have a look in the detail. And we love talking about migrations as you posted it, so feel free to get in touch. I'm sure we can give you a hand in some way, shape, or other. Great. Thanks so much, everyone. Thanks.
Thanks for watching. Bye.